everyone, for today's lesson we are going to learn about parabolas, but not just any sort of parabolas. We're going to be learning about properties of parabolas that we've never really thought about before. Before we get started though, hopefully you have already wrote down a few things that you know about parabolas, recognizing that the warm-up was already given to you. But if you have not, I've written down a few things that I know about parabolas. I know that a parabola has a vertex. It's U-shaped. It's part of our quadratic functions that we learned about. It has a symmetric shape. It has an axis of symmetry. If we were to write out a table of values, our table will be symmetric around our vertex. There are three different forms we've already learned about. That's standard form, intercept form, and vertex form. And there are many, many more properties of parabolas that you might have written down that just scratches the surface. But our learning targets for today are for you to be able to say, I can identify the vertex, focus, directrix, and axis of symmetry of a parabola. So these are just additional properties of parabolas that we're going to be learning about today. I also want you to be able to say, I can use this information to graph a parabola, pointing to the left, the right, up, or down. So we've already graphed parabolas that are pointing up and down, but the new ones are pointing left and right, and they have a special property when it comes to their equation. I also want you to be able to say, I can write the standard form of a parabola given the directrix or a focus. So let's go ahead and talk about example number 1. In example number 1, we have y squared is equal to 20x. And we're not used to the fact that this has a y squared. We're used to parabolas looking like y is equal to ax squared plus bx plus c. We're used to parabolas having an x squared in it. That's how we always know that it's a parabola. It's quadratic. It falls into the quadratic family. And so for us to start off with having a y squared, that's different. And so one thing that is different is now parabolas could point to the left or right. So if you see a y squared, which is different than what we're used to, then that automatically tells you this graph is going to be different. This graph could point to the left or it could point to the right. So how can you tell? Well, if it's pointing to the left, that'll indicate that we are working with negative values. And if it's pointing to the right, that indicates that we're working with positive values. So pointing to the left means that we're going to have a parabola that's pointing to the left. And if it's pointing to the right, that means that we'll have a parabola on a graph that's pointing to the right, hugging all of our positive x values, and pointing to the left is hugging all of our negative x values. So the way that you can tell is your number next door to x. And our number next door to x is positive. So that tells me automatically that my parabola is going to be pointing to the right. So now what I'm going to do is I'm going to talk to you guys about the standard form of a function. The standard form of any graph that is written in the form of y squared or x squared is going to be written in the form of y squared is equal to 4px. And the letter P has meaning. That letter P tells us our focus. So in this problem, we have y squared is equal to 4px, and our standard form is y squared is equal to 20x. So what's nice about this problem is that it's already written in standard form. You always want your equation to start off with a squared term equals something times the other variable. So it'll either be something times x or something times y, depending on the function. So now what we want to do is we want to identify what our vertex is. So just like whenever we've worked with standard form in the past, when we did not have a C or a B value, our vertex was always located at 0, 0. And so for every problem that I'm going to give you, our vertex will also be located at 0, 0. So that should be an automatic point. The vertex is located at 0, 0, and I'm going to plot 0, 0. And I'm going to use this space just below the graph in order to give some explanation. So the first thing that I want to write down is that if you see a y squared in the equation, then that means it's either pointing left or right. So that's the first thing I want you guys to write down. If you see a y squared in the equation, it's either going to point to the left or right. It's going to point to the left if p is negative, or if the number next door to x is negative, or it'll point to the right if the number next door to x is positive. So left is going to be negative and right is going to be positive. So that's something that I want you guys to keep in mind. The next thing that I said to you is that P represents your focus. So what is a focus? Well, a focus is a point. If I were to draw a really quick sketch of what a parabola would look like and what a focus is, we're going to draw, this is what our parabola pointing to the right is, and a focus is a point that is going to be hugged by the parabola, and it's going to be equidistant away from any point on that parabola. It's going to be equidistant away from any point on that parabola as the directrix line is. The directrix line is going to be a vertical line that does not intersect our parabola. What that directrix line is it's going to represent a distance. So the distance that focus is away from any point onto our parabola is going to be equidistant to our directrix. So those 2 points are going to be equidistant from any point on a parabola. So the distance between the focus and our vertex is going to be equidistant from our directrix line to our vertex. So this is our relationship that we're going to be looking at. So try not to overthink this too awful much, but here's what our focus is going to be. Our focus is going to be a certain ordered pair. So here's my focus. It is going to be the ordered pair p comma 0, and that happens if p is next to x. So what I mean by next to x is that we have 20 next to x. That indicates that we're going to be working with a p-value that is going to be our x value. So we have ourselves our ordered pair of p comma 0, and that happens if p is next to x. P could be next to y depending on the type of function that we are given. Please note that the parabola always hugs the focus. So it always kind of gives it a hug or surrounds the focus. So just keep that in mind as well. All right, so that is our information about a focus. So how do you identify what that focus is going to be? Well, notice that 20 is located in the 4p position. What we can do is we can set 4p equal to 20, and we can solve for p. So if I were to divide both sides by 4, we would find that p is equal to 5. So what you do in order to identify that is, since we know our parabola is pointing to the right, I'm going to go to where my vertex is, and I'm going to count 5 units to the right. So I know that my parabola is going to open up, and I know that my parabola hugs my focus. So I'm going to simply count 1, 2, 3, 4, 5 units. And that is my ordered pair for my focus. And so my focus is going to be located at 5, 0. My directrix is equidistant from any point on our parabola, including the vertex. It will share the same distance that the focus has away from a certain point. So if our focus is 5 units away from our vertex in one direction, our directrix is going to be 5 units away from our vertex in the opposite direction. So I'm going to count 5 units to the opposite way. So I'm going to count 1, 2, 3, 4, 5. And I'm going to plot a quick point. And from that point, I'm going to draw a vertical line going through that point. And this represents my directrix line. A directrix is a line. It can either be vertical or horizontal depending on if our graph is pointing to the left, right, up, or down. In this case, because our graph is pointing to the right, we're going to have ourselves a directrix line that is vertical. So our directrix line is always going to be vertical if we have ourselves a parabola pointing to the left or right. So we have ourselves our directrix line. And the way that we found it is we counted it's equidistant away from our focus and equidistant away from our vertex as the focus point is. So if our focus point is 5 units to one side, our directrix line is going to be 5 units to the other side. These two distances need to be identical and the same. So our directrix line is going to be a vertical line. And that vertical line is going to be in the form of x is equal to the opposite of p. So if we found p to be 5 in this problem, we would have our equation of this line be x equals -5. These two numbers should always be, so the directrix and the focus should always be opposite signs of each other. Always. If they are the same sign, then that tells you that you did something incorrectly. And in order for you to identify this directrix line, we always count p units away from the vertex. So in order for you to come up with your focus, we count. In order for you to come up with your directrix line, we count. So that's going to be something that's important. You simply need to count. Instead of focusing on like what the ordered pairs are and what the equations are, simply count and use a little bit of logic in order for you to come up with those values. So now we have an axis of symmetry. And since we know our parabola is pointing to the right, our axis of symmetry is still going to be a line that would cut your parabola in half. That would show that we have symmetry on each side. And in this case, we would have ourselves an axis of symmetry that is going to be our x-axis. And our x-axis is the equation y is equal to 0. So it's either going to be y equals 0 or it's going to be x equals 0, depending on if your graph is pointing left or right, up or down. So let me just recap, and I'm going to use a little bit of color. The first thing that we have here is a focus. And in order for us to come up with our focus, we took 4p and we set it equal to the number in front of x. And we solved and found that the number was 5. And since our graph is pointing to the right, since we have ourselves a y-squared situation, which is different than what we're used to, we have ourselves a graph that's going to be pointing to the right, which is something that we're not used to. So we started at our vertex and we counted 5 units to the right. And that represents our focus. The next number that we came up with is our directrix. And the way that we came up with our directrix is we counted backwards 5 units. And then we drew a vertical line because this line needs to be like the saucer to your teacup. The saucer should not go through your teacup. Your teacup needs to rest onto your saucer, and your teacup needs to be your parabola. So we call this our teacup. Our saucer is going to be the directrix line, and our focus is just that little bit of sugar that's always inside of the cup. So that's just a little phrase and a little fun thing that I always remember. And then I used to remember parabolas. Then we have ourselves our axis of symmetry. Our axis of symmetry will either be the x-axis or the y-axis, depending on if it's pointing to the left, right, up, or down. If it's pointing to the left or right, our answer will be the x-axis for our axis of symmetry. If it's pointing up or down, it's going to be our y-axis. And this still represents the line that will cut our parabola in half. So now we're ready to come up with our table of values. So when it comes to our table of values, we need to select values of x that are going to be to the right of our vertex. So pointing to the right means that we're going to select the number 1, the number 2, and the number 3. You do not need to fill out the entire table. What we're going to do is identify those values, and then once we have those values identified, we're just going to do a quick reflection and just count over on the other side to find what our other values are going to be. So I'm going to let x equal 1. So we're using the equation y squared is equal to 20 times x. So I'm going to let x equal 1. So I'm going to go y squared is equal to 20 times 1. So I'm going to write y squared is equal to 20, and I'm going to take the square root of both sides. I do not need these to be in simplified radical form. It's easier to work with decimals, and we find that y is equal to plus or minus 4.5 if we were to round to the nearest tenth. So 4 plus or minus 4.5 is what we are going to plot. I'm going to go over 1 and count up 4.5. 1, 2, 3, 4, and a little bit. Counting down 1, 2, 3, 4. And a little bit. These are going to be approximations since we're working with decimals. So just keep that in mind. Next, I'm going to let x equal 2. So I'm going to go y squared is equal to 20 times 2. So if I have y squared is equal to 40, I'm going to take the square root of both sides, and we find that y is equal to plus or minus 6.3. So I'm going to go to where 2 is, and I'm going to count up 6.3 and count down 6.3. So I'm going to go over 2 and count up. Here's 5, 6, and 6.3 is just a little bit more. So here's 5, 6, and just a little bit more. Once again, this is just going to be an approximation. Next, I'm going to let x equal 3. So I have y squared is equal to 20 times 3. 20 times 3 is 60. So I have y squared is equal to 60, and we're going to take the square root of both sides, and we find that y is equal to plus or minus 7.7. So I'm going to go over to 3, and I'm going to go up. Here's about 7. 7.7 is almost to 8. So I'm going to go over to 3 and down here 6, 7, 7.7 is about right there. Now I'm going to draw my parabola. It's going to be a smooth curve. It's still going to look parabolic in shape. It's still going to look like a U. It's just that U is going to be pointing to the right this time. No big deal. And here's what my parabola looks like. We always draw arrows, and we need to make sure our graph is pointing from end to end, and we need to graph that to the very best of our ability. So that is what we have whenever we're graphing a parabola whenever we have a y squared. It's going to point to the left or the right, and we have to make that decision at the very beginning. Let's go ahead and look at example number 2. In example number 2, we have ourselves y is equal to negative 1/4 x squared. It has an x squared in it, which means that it's going to be normal, what we're used to. So it's going to point either up or down. How can you tell if it's pointing up or down? It depends on the number in front. And the number in front in this case is negative, so that indicates that it's going to be pointing down. So now we have to rewrite this equation in standard form. Standard form, whenever you have an x squared, is going to be x squared is equal to 4p times y. Unfortunately, x squared is not alone in this case, so we need to make sure that whenever we write something in standard form that the squared portion is alone. So in this problem, we need to get x squared alone. That is going to be our first step. So in order for me to get x squared alone, I need to get rid of this negative 1/4. So what I'm going to do is I'm going to put parentheses around both entire sides, and I'm going to multiply both sides by negative 4. When you do that, the multiplication of negative 4 eliminates the division of negative 4, leaving us with just x squared. And then we have x squared is equal to negative 4y. So that is our standard form of the equation. Our vertex is still going to be 0, 0, and it will always be 0, 0. And now we need to talk about our focus. So I'm going to plot my vertex at 0, 0, and we're going to talk about the focus. The focus, so before I even do that, I'm going to write if you see an x squared in the equation, then it is opening up or down. All right, so now let's go ahead and talk about our focus. Just like in the last problem, we're going to be counting. Since we know that our graph is going to be pointing down, I'm going to start at my vertex and I'm going to count down p units. So that ordered pair for our focus is going to be located at 0, p, and that is if p is next to y in the standard form. And in this case, our standard form, we have a number next door to y. So if we wanted to find what our focus is, I'm simply going to set 4p equal to -4. I'm going to solve for p by dividing both sides by 4, and we find that p is equal to -1. So what that means is that I'm going to count 1 unit going down since since we're pointing down. So I'm going to simply count 1 unit from my vertex going down. So here's my vertex. I count down 1 point, and that represents my focus. My focus, this ordered pair right there, is located at 0, -1. Once again, our parabola will hug the focus. So the parabola always hugs the focus. It's the sugar inside of your teacup. That's the thing to remember. Next, if we want to find our directrix line, just like we did before, if we counted 1 unit down to find our focus, we're going to count 1 unit up in order for me to identify my directrix. These 2 points need to be equidistant away from our vertex. So the directrix point and our focus point need to be equidistant away from the vertex, and I'm going to draw a horizontal line going through my directrix point. And this equation of this line is going to be located at y is equal to +1. The focus and the directrix need to be opposite signs of one another. And so when it comes to your directrix line, it's going to be a horizontal line that will go we'll call y equals the opposite of p. So those are going to be opposite numbers of one another. And you're simply going to count p units away from the vertex. And it's going to be in the opposite direction. So if we're going down, we're going to count up for our directrix line. If our parabola is pointing up, then we're going to count down for our directrix line. So now we need to identify our axis of symmetry. Our axis of symmetry, since we anticipate our parabola pointing down, our axis of symmetry is going to be the y-axis. And our y-axis has the equation of x equals 0. So it's going to be a vertical line. So now I'm going to use a little bit of color just like I did before. And I have my focus is going to be located right here. Here's my focus. My directrix is going to be a horizontal line. My symmetry is going to be a vertical line, axis of symmetry. And now I'm ready to come up with my table of values. So when I come up with my table of values, I have to think about this logically. So I'm just simply going to identify positive x values, and then I'm going to reflect those values across the y-axis. So once again, I'm going to choose 1, 2, and 3, because 1, 2, and 3 I'm allowed to use. And then once I've used 1, 2, and 3, I'm simply going to reflect these points across the y-axis. So it's going to be on the other side. So I'm going to let x equal 1, and I'm going to plug it into my original, or my standard form function. So my standard form function is x squared is equal to negative 4y. So I'm going to write x squared. So my x value is 1, so I'm going to go 1 squared is equal to negative 4 times y, and I'm going to solve for y. So I'm going to divide both sides by 4, negative 4, and I end up with negative 1/4 is equal to y. So I'm going to plot the point 1, negative 1/4, and approximate where that's going to be. And that's just going to be right about there. And then I'm going to count or reflect this point across the y-axis. So I'm just going to plot that point right there. And now I have my reflection. Next, I'm going to let x equal 2. So I have 2 squared is equal to negative 4y. So I'm going to divide both sides by negative 4, and that's going to be 4 over negative 4, which is negative 1. So negative 1 is equal to y. So I'm going to go over 2, down 1, and I'm going to reflect that point across the y-axis. So that's 2 units away from the axis of symmetry. I'm going to count 2 units on the other side. Next, I'm going to let x equal 3. So I'm going to go 3 squared is equal to negative 4 times y. I'm going to divide both sides by negative 4, and we end up with negative 9/4 is our y value. And since it's a lot easier to work with decimals, I'm simply going to write that as negative 2.25. So I'm going to go over 3 and down 2.25, which is going to be about right here. And then I'm going to reflect that point on the other side. And now I have all of the points that I need in order for me to draw my parabola. Make sure your parabola extends the entire grid and is pointing in the correct direction. Make sure that your parabola is hugging your focus, and make sure that it does not cross your directrix line. And it looks like a cup with a little bit of sugar inside and a saucer. So we have a teacup and a saucer. Let's go ahead and move on to the next page. For the next page, what we are going to do is we are going to be given a directrix or a focus, and we are going to write an equation of a parabola in standard form. So based on our directrix and our focus, we have to decide, is that parabola pointing to the left or right, or is it pointing up or down? So when you are asked to write the standard form of the equation of a parabola, it really helps to draw a quick sketch. Nothing beautiful, nothing perfect, just a quick sketch, just to make sure that you're coming up with the right kind of equation. This sketch will help you to determine the opening of the parabola and in turn which equation to use. Also, please be cautious of the sign of P. So you want to make sure that you're very careful when it comes to the sign of P. Let's go ahead and look at the first one. We have ourselves the directrix is located at y equals 2. So y equals 2, that is a horizontal line. So I'm going to go to where y equals 2 is. I'm going to say that it's approximately right here, which indicates that our parabola is pointing down. And so since our directrix is 2 units away from our vertex, I would anticipate that my focus is going to be 2 units away from the vertex as well. And at this point right here, P is equal to negative 2. So if our directrix line is y equals positive 2, our P value is going to be negative 2 because it's going down. That would be the ordered pair 0, negative 2. And since it's pointing down, we're used to parabolas pointing down. That indicates that we're going to be working with x squared is equal to 4p times y. And since my p value is going to be negative 2, I'm going to simply write this as x squared is equal to 4 times negative 2 times y. So my standard form equation is x squared is equal to negative 8y. And that is it. Let's go ahead and look at letter B. For letter B, I have my directrix line is a vertical line and x equals 4. So I'm going to draw where x is equal to 4, and that means that it's going to be 4 units away from our vertex. And that also indicates that our parabola is going to be pointing to the left. Pointing to the left, not anything that we are used to. So that indicates that we're going to be working with y squared is equal to 4p times x. We would anticipate our focus being 4 units away from our vertex. So that indicates that our p-value is equal to -4. So we would anticipate that that ordered pair would be located at -4, 0. So our p-value is -4. The directrix and our focus is going to be opposite signs, and so now we can write our equation. Y squared is equal to 4 times -4 times x. So our equation is y squared is equal to -16x. Let's go ahead and look at letter C. For letter C, our focus is located at -2, 0, which is nice. We know our focus is going to be -2. What we need to decide is what is the orientation of our parabola. So -2, 0 is going to be located right here, which indicates that our graph is going to be pointing to the left because our parabola always hugs our focus. And if it's pointing to the left, that's not anything that we're necessarily used to. So we're going to be working with the equation y squared is equal to 4p times x. So I'm going to write y squared is equal to 4 times -2 times x. And 4 times -2 is -8. So our equation is y squared equals -8x. And finally, our focus is located at 0, 3, which is cool. We know what our focus is, our p-value. But now we need to decide, is this pointing up or down? And so I'm going to plot where 0, 3 is, and that is going to be on our y-axis, which indicates that our parabola is pointing up. Since it's pointing up, we're used to problems where it's pointing up. So we're going to have x squared is equal to 4py is our equation. So I'm going to let 3 equal p, and I'm going to write x squared is equal to 4 times 3 times y. So my equation is x squared is equal to 12y. So next, let's go ahead and state the equation of the parabola. So it's just going to be like the information that we have up here, where we're going to be trying to identify what our focus is and trying to decide what type of function to use. Since this function is pointing to the left, that indicates that we're going to be working with y squared is equal to 4p times x. My focus is -3, so my p-value is -3. So my equation is going to be y squared equals 4 times -3 times x. So therefore, my standard form equation is y squared equals -12x. So now we're going to use this information in order for us to identify how deep a mirror is for a parabolic reflector. So here's some background knowledge on parabolic reflectors. It says parabolic reflectors have cross sections, which a cross section means that if we were to slice a shape that kind of looks like half of a sphere in a certain section. So if we were to cut this in half, it would create a parabolic shape. So parabolic reflectors have cross sections that are parabolas. Incoming sound, light, or other energy that arrives at a parabolic reflector parallel to the axis of symmetry is directed to the focus. Similarly, energy that is emitted from the focus of a parabolic reflector and then strikes the reflector is directed parallel to the axis of symmetry. So this is our background knowledge of parabolic reflectors. The most important thing is that you know that it's going to be based on a focus and that the cross section is going to be in the shape of a parabola. So in example number 5, it says a flashlight uses a parabolic mirror and a light source. The parabolic mirror is going to be our parabola that we're going to be working with, and our light source is going to be our focus because our light source is going to be located inside of our parabolic mirror. We want to write an equation for the mirror's cross-section, which just means that write an equation for this parabola that's going to be located on the outside. And then we want to figure out how deep the mirror is. So I have this parabola going from end to end, And we need to just identify what that equation is. So since that picture appears to have a parabola pointing up, I'm just going to go with it, and I'm going to draw a parabola that is going to be pointing up. I'm not going to put arrows at the ends because it looks like this parabola stops, and so will mine. If we look at our length from end to end, it appears as if this length from end to end is 4 inches, which means from our center going all the way over is supposed to represent 2 inches. So this is supposed to be 2 inches. And then from end to end, that's supposed to be 2 inches as well. If you guys look right here, we have this 1/2 inch. And this light bulb is or our light source is what we consider to be our focus. And our focus is about 1/2 inch up. So if I were to approximate where 1/2 inch is, that's where my focus is. And my focus is going to be located at 0, 1/2. So that is supposed to be a 0, 1/2. All right, cool. So now that I've drawn this picture, I now can see that this parabola is pointing up. And since that's something that we're comfortable with, we're going to be working with the formula x squared is equal to 4p times y. And I know that my p value is going to be 1/2. So I'm going to write p is equal to 1/2 right here. So since I know that my p value is 1/2, I'm going to simply go x squared is equal to 4 times 1/2 times y. So my equation is x squared is equal to 2y. Cool. Now I need to figure out how deep the mirror is. So that means that I want to figure out at my highest point, how tall is it? Okay, well what I do know is that if I were to go over 2 and then up some y value, I would land at this point. So this is going to be 2, comma, I'm going to call it question mark. I'm not sure what that value is going to be. What I can do is I can let x equal to and then solve for y. So that's exactly what I'm going to do. I'm going to let x equal 2 and I'm going to solve for y. So I'm going to go 2 squared using my formula. 2 squared is equal to 2 times y. 2 squared is 4, and so I have 4 is equal to 2y. Dividing both sides by 2, I find that y is equal to 2. And what that 2 means is that the mirror is 2 inches, because we're talking about inches, it is 2 inches deep. And that is the end of this video. If you have any questions over anything, please feel free to email me. Otherwise, I hope you have a wonderful day.